good distribution and looks like it has a nice flow going on. Looks like my resources are distributed well and the flow through of my economy is awesome. All right, take that, Prussia. Damn it. Is this thing on? Yeah, it looks like it is. So, the executives just got back from their corporate retreat, the annual corporate retreat, and they want to know exactly why numbers are down. Why do we see fewer customers now than we were seeing earlier? So I want you guys to go ahead and put together a quick model out where we see customer growth going in the next quarter, put some graphs and stuff together, and make sure that they are easy to understand. That way we can explain it to the executive team and I can present it to them easily. Give me a quick write-up and everything. That way it's easy to present it to them. They are meeting again tomorrow on Friday, so make sure it's in by then. Let me know if you have any questions. I will be available on Slack. Well, that sucks. Well, whenever you get a complicated problem like this, right, like a project-based problem, it's very important to first outline exactly who is going to be doing what. So let's go ahead and look at what a data team does and what precisely we want to accomplish. Okay, so what is the role of a data team? In most organizations, a data team has one job, and that is to provide something we call decision support. Meaning that the data team will provide the information necessary for other teams that actually take action and like execute on business objectives to make decisions. So this can be anything as simple as we provide a dashboard that shows exactly what the major KPIs, key performance indicators, are and how they're performing in live time, to something as complicated as building a very advanced trading model that will trade stocks automatically for us. At the end of the day, the decision-making part of that model is built by us, and the software is usually built by a team of software engineers. To achieve that objective, data engineering or data teams usually have three major positions. What I like to call the data engineers, and this can include anything from a data engineer to a machine learning engineer, or even a software engineer that works in the data organization. Basically, any engineers working in the organization, they will fall under this category. Then you have the data science team. So this can include data scientists, research scientists, you'll have like machine learning scientists. These are basically anyone with the word scientist in their title, and certain data analysts would fit into this box. And then you have people that kind of fall into the analytics role. So these are your data analysts, your BI people, sometimes your BAs, business analysts. They all fall under this role. So this is what I would say are the three major roles of a data team. So we'll put one over there, we'll put one over here, and we'll put one over here. And then if you want to talk about kind of like the life cycle of a data project, there are many different models as to how one works. Crisp DM is usually my favorite one, but we're going to just kind of outline a self-made one over here where usually we'll start with a very simple one. You'll start off with raw data. You'll go into some form of modeling. Then you will put the data into some form of consumption layer. And we'll explain what all these are in a second. And then what we'll call prod. So these are kind of like the four major steps you'll see in a lot of data projects. Raw data is basically data in its most raw form, right? So if you, for example, are building a trading bot, this would be data coming straight from the stock exchanges. This would be maybe your raw Twitter data you're using to build out a model, stuff like that. So let's start off with data engineering. Data engineering usually works at the first and last part of the data lifecycle. So a data engineer will oftentimes work with the raw data, and then they'll also work to make sure things in production actually stay in production. Now, what is production? Production means after you have, say, created your model, a machine learning engineer or a data engineer of some kind will make sure that that model actually can run inside the real life environment you have. So for example, let's say you have a website and you have a suggestion algorithm that your data scientist built out. The people who actually put that suggestion algorithm on the website for the customers to see are going to be engineers of some kind. I'm just broadly calling them data engineers, although they might be machine learning engineers or just regular software engineers. So what are the skills you usually need for a data engineer? You need very advanced SQL skills. Everyone in the data team actually needs to know SQL, but the data engineer definitely knows SQL at the highest level of proficiency. Then you'll need some form of coding skills, right? So data engineers have some form of coding skills, and this can be either Python, which is the most popular language, and/or what we call JVM languages, Java Virtual Machine languages. And these are things like the language Java or Scala, which are like languages that form the backbone of a lot of big data frameworks. The next thing that a data engineer has are ETL or ELT skills. So ETL/ELT. And this is extract, transform, load, or extract, load, transform skills. So these are the ability to extract data from some data source, either load it into a data warehouse or to transform it and into like some format that you can actually use, and then load it into something else that a data scientist or data analyst can then easily consume that data in. Data almost always comes in very, very raw and unfiltered, unrefined formats, and it needs to be put in an easy-to-use format in order for analysts and scientists to actually use it. So that's the ETL ELT process. And then finally, a lot of data science or a lot of data engineers have a great knowledge of how the cloud works. AWS, Azure, GCP, these are all major cloud services, and how those services work together and how to create a good pipeline from end to end with these services is an important skill for a data engineer to have. So that is what the data engineer will be doing. On our team, we need to build out a model that'll predict 1 quarter into the future of how we expect to see customers, either leaving or entering our platform. All of the data that we're going to be using for that will be put into a database ready to use by the data scientists. That will be done by the data engineers. Now, a data scientist usually works on this section over here, the modeling, and then occasionally the consuming section, where they will build a model of some kind in order to model out data and say, okay, given we have this data over here, this is what we think it'll look like in the future. I like to say that data scientists oftentimes take data that exists and create data that doesn't exist. So for example, let's say you have a bunch of retail stores. It's one of my favorite examples. You have a bunch of retail stores. You don't know what your store traffic is, how many people are in the store at any given time. A data scientist can create a model using some other data that your data engineers put together that will kind of predict how many people are in the store at any given time. That is what a data scientist does. So they have SQL skills. They usually have mathematical skills. They will oftentimes have machine learning skills, which relate very closely to these mathematical skills over here. They will know either Python or R, and they typically will know these at a lower proficiency rate than a data engineer will. But obviously, they also are a lot more skilled at math than most data engineers are. And those are typically going to be your biggest skills for a data scientist. And as a really good data scientist will also have some good communication skills, although I would say these skills over here are usually more important for the data scientists. Now, moving on to the data analyst, right? Like, so in our company, in the task we have right now, after the data scientist creates a model of, future customer projections, it'll be up to the data analyst to actually put that model into something that can be easily consumed. So I like to say the data analyst works over here on the consumption part of the chain. So what they will do is they will have BI skills, so BI as in business intelligence tools, like Tableau, like Power BI, stuff like that. They will have the skills necessary to take the model to translate the technical things that the data engineers and the data scientists are doing into something that the business can understand. So what they'll do is they'll take this model that our data scientist is going to create about what's going to happen in the next quarter. They'll translate it into kind of like words, into charts, and create a visualization that can then be used by the executive team to actually make a decision. Oftentimes, the data analysts will also have good business knowledge. Like maybe if we say that there's a huge spike in sales in the next, or customers entering in the next quarter, the data analyst might say something along the lines of like, "Oh yeah, it's because we plan on launching a big marketing campaign, like, or because it's Black Friday or something like that. Like that's going to happen most likely." A lot of this business knowledge comes from data analysts. So data analysts have SQL skills, they have BI skills. Very rarely they will have coding skills. In my opinion, a good data analyst will eventually pick up coding just because it's so useful to their career. But most data analysts I've met don't have coding skills. But usually SQL, BI, and then excellent communication skills. Excellent communication skills are a complete like boilerplate. You have to have this as a data analyst because oftentimes people will come to you first to ask how things work, and it's up to you to determine if we need to escalate this to a data scientist or a data engineer. And even then, what should the data scientist and data engineer be aware of when they're working on this project? So in our project, we're going to have our data analyst create our dashboard to actually consume the data. Oh, speak of the devil, looks like we got an email from our data scientist. Looks like they're getting caught up on some environmental setup issues. This is a really common problem you'll see in any data organization, or even in software development organizations. The environment is basically kind of the setup your computer has in order for you to actually start coding and actually start developing stuff. And environment setup is actually one of the biggest issues in the field because everyone's computer is slightly different. People use different chips. Some people use Windows, some people use Macs. Amongst Macs, some people use the M1 chip, some people use regular Intel chips. And so environment setup is a major issue. And today I'll be showing you guys how to get over those issues. But it looks like they have an environmental setup issue, so we're going to be using something called Deep Note to just completely bypass all that stuff. And they need data to build their model. So can I help them out? As a data engineer, this would be part of my job. So let's go ahead and open up an S3 bucket for them. S3 stands for super simple storage, and it's basically just a place where you can dump a bunch of data. It's a data lake, basically. A data lake is basically the junk drawer of any data organization. So I'm going to go ahead and put their data in the data lake. That way they can easily access it. And let's see, I'll just call it your data, make it easy for them. And then we'll keep it like that. Keep it like that. And then I will go ahead and create the bucket and just add a file to it. So there's our bucket. And I think I can just upload a file. And what this will do is this will actually upload this data file that the data scientist wanted into an S3 bucket. And from there, I can give them a notebook that'll directly connect to this S3 bucket. That way they don't have to worry about any environmental setup. And I'm going to be using something called Deep Note. That way I can show them how to do it in real time because we're all working remotely. The data scientist lives somewhere else. Tools that allow you to collaboratively work together are definitely the way to go. But what I will also need is I will need to give them something called an IAM. I will need to go work on my IAM permissions, basically identity and access management. So I can go over here and notice how I'm using AWS to do all this. Again, remember how this is a skill for people who work in data engineering. So what happens is you don't want to just have a data scientist, or you don't want to have just people have access to your S3 buckets. And this is all stored on the web, right? So you want to make sure that you control who can access and who can't access your stuff. So I'm going to go over here. I'm going to go ahead and create a new user for the data scientist. That way they can easily access the data. I'll just call this data scientist. I'll give them programmatic access. And this is what I mean by having to know how these services work. And I'm just going to give them full access to S3, which is basically where we stored our data. And because we are working on such a short timeline, I'm just going to put the data in the data lake. I'm not going to organize it. That way they can get to working with it as soon as possible. All right, so now they have a key, which we will go ahead and put in our Deep Note workbook for them. So let's go ahead and we'll just call this data science data. And I think the bucket's name is your data, your hyphen data. So I like to do your data. And then let me give them the access credentials. These need to be kept very secret. Whoops, I did not mean to do it that way. Oh, I didn't actually create the user. There we go. Create the user. And now we can go ahead and give them their access keys. And I'm just going to go ahead and do this for the data scientist because we are on a bit of a tight schedule. So I will do this for them. But by doing it this way, we completely bypass the need to work on any, to go and like set up their computer and stuff like that if we do it on Deep Note. So let me go ahead and get this ready. We'll create a new workbook for them. And we'll call this customer loss model. And then let me go ahead and just share this with them right now. And I will respond to the email sending this to them. All right, so I sent the data engineer the data that I needed put into a data lake, otherwise known as an S3 bucket. And I was telling him that I also had some issues with my environment setup. And he said he had some solution called Deep Note, which is apparently some cloud notebook that allows you to do things like not worry about environment setup because everything is set up on the cloud, and even do things like pair programming. Actually, he sent me a link just now, which I will open here, where he's going to show me how to actually set up a notebook. I think he's even going to do it for me. Oh, wait, that's so cool. I can like see him typing over here. All right, so he saved all the files in an S3 bucket and configured The deep note notebook. Okay. So an S3 bucket is just a place where you store data. And as the data scientist, sometimes I'll do this work myself. Oftentimes you really rely on data engineers to make sure all of your data comes in cleanly. That way we can really focus on the actual modeling exercise. So in a very small company, the data scientist might do everything. But in a larger company, in a very well functioning data organization, the data engineers will take on the task of actually making sure data is ready to go. All right, so it looks like I won't have to worry about pesky environment setups again. Okay, so I'm guessing what he did over here is he connected. Oh, so it looks like this deep note thing has a lot of integrations with different different data providers. In this case, it's just a couple of links and stuff he configured. He made a user and everything for me in order to actually access the data. Again, these configurations on cloud services are usually handled by the data engineers, who then give us the credentials where we can actually go ahead and get access to the data. It's so that everyone can do what they do best. They specialize at these integration stuff, and we specialize at actually modeling out the data. Okay, so pandas, that is the library we use to access tabular data. And it looks like we have our air traffic passenger stats data right here. Perfect. This is exactly what I needed to model out the data. Awesome. So it looks like we have the file right here. Let's go ahead and take a look at it. So awesome. Okay. This is exactly what I was looking for. Now I'm going to go ahead and go through the modeling process. Now, as a data scientist, oftentimes I'll have to do some of my own data cleaning. And the reason I'll have to do some data cleaning is because the engineer doesn't necessarily know what format I need the data to be in order to actually run my models. But as a data scientist, I know. The data engineer is usually worried about things like basic formatting, making sure dates show up as dates, making sure that really long strings actually fit into stuff. So like really basic forms of formatting to make sure I don't have to deal with any really base level data cleaning. But as a data scientist, I need to actually filter out the data and clean it to get to the format that I need. So it looks like I only need a couple of things over here. So I am going to only look at filtered data for the operating airline as American Airlines. And I also only want to get passengers that have deplaned. So I'm going to add this over here. Data import activity type code equals deplane. Looks like we have a couple of columns over here. Operating airline would be the airline that we care about. And then activity type code, whether someone is deplaned, inplaned, or is through transiting. So we only care about deplaning and inplaning. And then I also want to make sure I sort the values by activity period. So you'll see over here under activity period, this is the actual date that we do stuff in. And then let us go ahead and also limit the columns to only the operating airline, the activity period, and the adjusted passenger count. And I'm going to reset the index. That way we only see what we want to see. And if I run this over here, then it looks like we have our operating airline for the activity period we care about and the adjusted passengers. Now, one thing I want to do is I do want to add a date column as a date. So, for example, you see this activity period over here, 2005 July, 2005 August, 2005 September, 2005 October. These are supposed to be dates, but they're not formatted as dates. So let me see if I can go ahead and fix that. So I think there we go. Here are all of our dates. So then what I'll do is I will say this is a column over here. So I will say filter data import date equals this. And there we go. That is our date column. So now let's go ahead and do a very simple linear regression on this data. So it looks like we're seeing a downward passenger trend over time. Now, what would happen if we were to do the same thing, but with just our regular Y? Yeah, it looks like it's trending downwards, and it looks like our model's not the worst thing in the world. We could probably use a more predictive model by using something like Facebook's profit library. So let's go ahead and try that. So this is very much part of the learning process for a data scientist. You try out one model, see if it works. It doesn't seem to work, so then you try out a new one. So let's go ahead and try this one out. There should be a very simple implementation here. All right, so wow, it's already done. Wow, that I can barely get it installed on my computer because of just some weird stuff that goes on with Macs, like the new M1 Mac. So I think, there we go. We have profit going in right now. So then let's go ahead and do a very simple future prediction. There we go. Okay, so they cared about the actual format that it was in. And then, oh, we can make future predictions. Okay, cool. So I want it to make, let's say, they said one more quarter, right? So a quarter has, so the manager asked us to do one more quarter worth of predictions. And these are, we have everything at the month level. So we'll do four more predictions. Oh, I guess we just add this in here. Cool. And then this is the actual forecast. Perfect. So Y hat is really what we're looking at over here. Awesome. So I'll go ahead and put this all together in a data set. That way the data analyst can put it together and add some business logic to it, and they can present it to the stakeholders. They know the business a little bit better than I do. I'm a lot more involved in the deep modeling of it. Okay, so the data scientist just told me that he finished building a model that'll forecast into the four next months of our cycle, which means one more quarter of data. So I don't really know how to use Python, which is why I'm glad he told me that apparently this deep note thing actually supports querying things with SQL. So it seems like everything in the data science lifecycle, from the data engineering to the data analytics work, can be handled in SQL. Because like many data analysts, I don't really, my Python skills are like okay, but I know SQL very well. And as a data analyst, my job is to take, or one of my many jobs, is to take the information given to me by the data scientist and put it together in a way that the business can actually understand it. They know what's going on. So let's go ahead and query the data. So he said something along the lines of like, there is a plot called data to plot, I think, and I can just do like a select star from that. Oh, cool. That actually works. It looks like it queried a Python data frame. Now, one of the many things you need to know as a data analyst is how much information you should actually be giving people in, like as you filter information upwards. Generally, the higher up you go, the less information you need to give. That way, people can actually make decisions on relevant information. Because people who are, really high up in an organization, they get so much information thrown at them. It's important to give them the information that actually helps them make a decision. That way, you reduce decision fatigue for them. So I am only going to include data from, so it looks like we go all the way up until the July of 2022. That's our future data. And I will only include data from the previous year up until this point. So August 2021 till July 2022. We don't really need any more data than that. So let's go ahead and just do a simple where statement. So where DS is greater than, and the cool thing about SQL is I think you can just treat this as a string basically. And then we will change this to say 2021, 08, or it needs to be greater than 07, 01. There we go. And there's our data. There's our limited data. Now I can go ahead and create a simple chart with this. That way we can go ahead and print it out and show it to our executives very quickly. We only have a little bit longer before we need to present this. And one thing about working on a data team is understanding how much work you can actually get done in a certain amount of time. And given that our executives didn't give us much time to get this done, we will give them a relatively simple chart. So let's go ahead. I think this is saved as something called DF1. I guess that means data frame underscore one. Oh, okay, cool. So it's a bar chart, and the x-axis can be this DS thing over here, and the y-axis can be our y hat. Cool. That's perfect. This is 1 year's worth of stuff. Okay. Oh, that's pretty cool. And you know what I might want to do? I want to add a column that says that these are in the future. So I think we have data up until March. These four are future things. It looks like we can add a little color over there. So I think I can add that using um, SQL over here. There we go. Red, blue, and then I can go down here and I can add color, and we can see our forecast is very clearly highlighted. Now I can change red and blue to say actuals and forecasts. So let's go ahead and do that. So if I do that, and I can do that, and then I can do actuals. And then I just need to refresh this. Actuals and forecasts, perfect. And then let's go ahead and rename the columns too to make them a lot nicer. So one of the skills you learn as a data analyst is that the attention to detail about things like the way things are named and stuff is very important for executives. So let's go ahead and rename DS as date, month, and I'll just put it that way. That way it's easy for people to know exactly what we're talking about. And then Y hat as passenger count. Oh, whoops. I probably need to change this to date, month, and passenger count. And then maybe color should be changed to data type. So we'll call this data type. And then let's go ahead and make this a capitalization to make it like look a little bit nicer. I'll even add a little space in there. Let's make it look a little bit nicer. Capitalizations make things look slightly more professional. So we'll do some quick transformations over here. I think that should all work just fine. So let's refresh this. Date, month, passenger count, and then data type. There we go. And here's a good visual for us to get started with. And I would say this is probably good enough for us to present to the executives for now and explain our reasoning behind. So let's go ahead and email this to the manager and see what they say. And that is what an actual data science team does in practice. The data engineer gets the data ready, the data scientist will model out the data, and the data analyst will make sure that that data can be communicated very well to the executives.